Hey friends, in this tutorial we're going to cover how to build visualizations using R. Now to do this we're going to work through the third chapter of the excellent book called R for Data Science, which was written by Hadley Wickham and Garrett Grollemond. And I'm going to put all the links in the description below so that you can follow along as we work through this chapter together. So let's move over to RStudio. The first thing we need to understand is that we need to load the tidyverse packages. Now the tidyverse packages let us use a tool called ggplot. Now ggplot is one of the plotting systems in R. So to use ggplot, the first step is going to be we're going to load the tidyverse packages. Now as you can see on my screen, I'm going to clear the screen and we're going to type library tidyverse to load the tidyverse packages into R. Now, if you have an error when you try to run that command, you'll probably need to install the tidyverse packages. And to do that, you can run this command. So if you run install.packages, tidyverse, and then push enter, that will install the tidyverse packages, which will let you build plots in R. So in my system, I've installed it, so I'm not going to go through that step, but that is the command that you'll have to run if you don't have the tidyverse installed. Okay, so the next step is we are going to build a plot. Now to do this, we're going to use the miles per gallon data frame. So let's type in MPG for miles per gallon. This is a data frame that comes with R, and we can see a number of characteristics of this data frame. So first of all, we have the manufacturer, which in fact, let's view. You can use this view command to look at the data and scroll through it. So to do that, okay, so we've got a manufacturer, so we've got Audi, we've got Chevrolet, we've got Dodge, and so on. Then we've got a model of the car, the, displacement, I think, year, and a bunch of other metrics. Okay, so to start with our first plot, I'm just going to close that. For our first plot, we are going to ask this question. Do cars with big engines use more fuel than cars with small engines? So how do we do this? Well, first of all, we are going to use two of the variables from this data frame. We're going to look at the displacement using this variable, and we're going to look at the fuel efficiency of the car, which is highway. I think it's highway. So let's build our first plot. To do that, let's type below, we'll type ggplot, to tell R to start building a plot. So ggplot will specify the data that we're going to use. So data equals mpg, and then plus geom point. And we'll talk through all these things in a moment. Geom point, and then we're going to specify mapping is AES, x equals displacement, y equals highway. Okay, so once we've typed that command in, let's push enter and generate our first plot. Okay, so as you can see, we have our first plot. And this actually has there's a negative relationship between engine size, which is represented by the displacement, and the fuel efficiency, which is represented by HWY here. Okay, interesting. So basically what ggplot does, you start to build a plot using this ggplot function, and then you need to add layers to it. And you add layers by adding, in this case, geom point. Okay, so the next step we're going to do is we are going to look at how we can understand something called aesthetic mappings. Now, what's an aesthetic mapping? Well, to do this, let's have a look at these data points, which are up on the right-hand side up here. These are kind of unusual. These seem like exceptions to this negative relationship. So what's the deal with these cars here? Maybe these are hybrid cars. So one way to look at this is to look at the class. So if we look back at our data frame, so let's view it again, you can see that our class, we have compact, we have midsize, we have SUV, two-seater, and so on. So maybe these are hybrid cars, which are these exceptions. So to investigate this, we are going to add a third variable by mapping it to what's called an aesthetic. So aesthetics would include things like the size, or the color or the shape of points in some data. So what we're going to do first is we are going to look at in fact, let's map the class of the car to color. So to do that, we're going to type in our previous command, so data equals mpg, and then we're going to specify g_on_point. So we're writing a similar command to before, so mapping, and then our aesthetic. So our aesthetic is still y equals displacement, x equals displacement, y equals hwy, and now we're going to see our color. Our color is class, and let's run that command. Okay, so now we have a graph where the class of the car now has a different color. So, okay, so now what we can see here is that these cars, which seem like exceptions to the negative relationship, are actually two-seater cars. So, basically, they're probably sports cars. So they'll probably have large engines, but they'll have like a small body, and so they'll have better mileage as a result. Now, we could do the same thing, but instead of using color, we could use size instead. So let's experiment with that. So if we use ggplot, and then we'll specify again g_on_point. Now, as you can see, I'm basically typing out the entire command again, but what I can do instead is I can delete that and just push the up key, and the up key will bring me back to the previous command. And so I can just go back and I can edit that command. And instead of color, well, let's specify size instead of class. So we get a warning message because generally, you shouldn't map like an unordered variable like class to an ordered aesthetic like size. But you can see that each of the different types of cars has a different size in this graph. Okay, how about the transparency? So another way we could do that, we'll go back using the up key, and now we're going to, instead of size, we'll use alpha, which is a representation of the transparency. Okay, so now the different car types have different levels of transparency, depending on the type of car. Okay, now one of the things you'll notice here is that basically we can also use this shape. So let's specify shape equals class. And now every car has a different shape. Now, unfortunately, by default, R will only specify up to 6 shapes, which means the SUV, the poor SUVs, have not been represented on this graph because they are a 7th type of car. Okay, so what's next? Well, the next thing we can do is we can actually change the aesthetic properties of our geometric object manually. So let's suppose we wanted to make all of our points blue. To do that, we go outside of the aesthetic specification and we say color equals blue. Now notice that this is outside of these parentheses. So now if we specify color equals blue, let's plot that and we'll see, okay, so here we have all of our points have been plotted in blue. Okay, so basically we have a number of options when we want to think about displaying points. So we could specify, for example, using the class, or we could have the size, or we could have the shape of a point. Okay, so next we're going to look at some common problems that arise when we build plots. So a very common problem that people encounter is that they don't have parentheses in the right place. So let's take this simple graph here. So let's the simple plot, there we go. Now, often people can forget to have the right parentheses. So let's try running that. You'll see here that R doesn't actually run that. It just puts a plus, which means that it still expects you to type in something. So to get out of that, you can use the escape key. If you type the escape key, that will quit out and you'll get back to the prompt where you can type in the commands again. Now, another mistake that people can make is that they can forget to put in the quotation marks in the right place. So maybe you have, let's say you have like that, and again, R thinks, I haven't seen a matching quotation mark. And so basically it doesn't let you type in another command and it doesn't run the command. So to get out of that, again, just type escape. Now, another thing that can go wrong is that when we're typing in a command, so let's say data equals mpg, it's possible to split these commands over multiple lines, but the plus sign has to go at the end of the line as opposed to at the start. So let's just type in like that. This will run okay. But suppose instead we ran like this. We said data equals mpg, and then we went to a new line, and then we did plus g on point, and then we had the rest of our command. I'm just going to copy and paste that in. This will actually generate an error. So basically, we need to make sure that we put the plus at the end of the line if we split it over multiple lines. Okay, now if you have questions about how to understand a command, there's a really useful command in R, which is just the question mark, and you can type in the name of the function. So for example, you could type in the name of the function ggplot, and that will actually give you the documentation over here in RStudio on the ggplot function. Or let's say we wanted to do the same thing, but for g on point. Again, here we can see the documentation for this particular function. So that's a really useful way to get help when you're going and using R. All right, next we're going to look at facets. So one thing that's really useful when we are dealing with categorical variables in our data, like class, for example, where it's like two-seater or SUV and so on, is to split our plot into subplots, and those are called facets in R. So to do that, we're going to use something called facet wrap. So let's again type in our command where we're going to have all of our, we're going to have like that. We're going to have our, whoops, let me split that, there we go. So here's our command. Now we're going to, in fact, let's put it over multiple lines just to kind of simplify things. So we're going to put it like that. And now we can also add another plus sign at the end and use the facet wrap function. So let's use facet wrap, and we're going to specify class and n row equals 2. And I'll talk through what these mean in a moment. So let's run that command. And now we can see that our graph has been split into different subplots. So let's suppose we wanted to actually basically split our subplots using a combination of two variables. Well, to do that, instead of using facet wrap, so again, I'm going to use up to go back to, in fact, where we can't do that. Let's go and run data equals mpg plus g on point. We're going to specify our mapping again. So we'll specify our mapping. And now we're going to specify facet grid, and then we'll specify drive and cylinders. And if we run that, now our subplot will actually be arranged based on the type of drive and the number of cylinders in the car. Okay, so the next step here, so what this is doing is it's basically saying, let's use these variables to arrange our subplot. So next, we're going to look at different types of geometric objects. So let's run two separate commands and we'll see how they're similar and how they're different. So let's first of all run this command. So this is our original graph. It looks like pretty good. Now, how about if we change geom point to geom smooth? So now we see a line that looks like this. Now, what's the same thing here? Well, basically what happens is that R uses what's called a geometric object, geom smooth or geom point, to tell R how to take the data and how to display it on the screen. So to change how our plot looks, we can use different geometric objects. Now, what if we wanted to change the type of line based on the drive? Because in R, each different type of geometric object can have different ways of representing the data. So let's use this other argument. We'll call it line type, and we'll specify the line type will be changed based on the drive. So now we can see that there are so now there are three different lines displayed there. So basically there's three different drivetrains, different types of drivetrains in the car, front, rear, and four-wheel drive. Okay, so, and you'll notice that our line type is different in each case. Now, what we can do is we can actually combine this with our raw data, with the original raw data. To do that, we're going to do a couple of changes to our plot. So first of all, we're going to specify that our color is also going to be changed based on our drive. So we'll run that command first of all. So now you'll see that the color is different in each case. And we're also going to add our original geom points. So to do that, we can just copy that, we'll paste it at the end, and we'll add our geom point. And we're going to retain everything else, but we get rid of the line type, because a point is not a line, obviously. So let's run that command, and you'll see, there we go. So now we can actually see how these lines are different, and they've actually been fitted on top of our original points. So ggplot provides a lot of different geometric objects. And if you want to find more, you can basically, if you go to the ggplot documentation, so if we look at ggplot, so we run that and look at the documentation, and you'll see let's scroll down. Whoops. Okay, so let's just look up geom point. So you can either find a list by following the documentation here, or else you can go to the RStudio website. In fact, if you just Google the different geometric objects in ggplot2, you will find a large list of those. So let me show you actually how to find those. So if we RStudio, one moment, and we're going to find these, and then there's actually a really helpful what's called a cheat sheet on the RStudio website. So I'm just going to paste that in to this here, and I'll put a link to this in the description below. Basically, this lets you find the different commands that you can use to represent different geometric objects. So for example, there are things like the geom line for a line plot, and then geom smooth, which we've been looking at, geom point, and so on. Okay, so let's go back to our RStudio. The next step is we're going to look at some ways to do statistical transformations on our data. So let's do a bar plot. So to do this, we're going to use a different data set. We're going to use what's called the diamonds data set. So let's look at the diamonds data set. So the diamonds data set looks like this. We have the carat of the diamond, the cut, the color, the clarity, the depth, and a whole bunch of other metrics. Okay, so let's build a bar plot. To do that, we're going to use ggplot. We'll specify data equals diamonds this time, as opposed to the MPG. And then we're going to use geom bar for a bar plot. Mapping equals AES for our aesthetic. X equals cut. Now we run that, and we see this very nice looking bar plot. Now, what we can see here is that along the bottom of the graph, we have the cut. But along the Y here, we actually have count. Now, if you look at our original data set, we don't actually have any count variable. So how did ggplot get the count? Well, ggplot uses what is called a statistical transformation, or a stat, to get this. So basically it takes the original data set, and then it uses the count stat, which basically counts the number of times that a particular cut appears, and then it uses the geom bar to generate a bar plot using the results. Now, we can actually use the stat, basically the stat count, pretty much interchangeably. So if we run this command, we can see that we get the same result. And that's because every geometric object has a default stat, and every stat has a default geometric object as well. Now, sometimes you might actually want to specify a default. You might want to specify a stat yourself. So one possibility, let's use this sample data from the textbook. So if we use the sample data, let's have a look at that. So demo, we have cut in our frequency. Well, maybe we would want to use basically the height just based on the frequency here. So the counts have already been done. We just want to use those. So if we just use our standard bar plot, it'll actually say that it's 1 in each case. So let's just generate a bar plot. So data equals demo, and then we'll say geom bar, and mapping is our aesthetic is our cut. And if we run that, it's gonna backfire. It'll say that it's 1 in each case because the count's already been done. But we can actually specify that our y is our frequency. Whoops, wait a sec. We need to specify stat equals identity. And that will actually use the frequency as the height for our particular plot. Now, another possibility is that you might want to override the mapping from transformed variables to aesthetic. So maybe you want to show proportion rather than count. So if we come back to our original diamonds plot, let's come back to our diamonds plot. We'll just scroll up and there we go. So if we run this is doing the counts, but maybe we want to look at the proportion instead. So to do that, we could use y equals stat prop. Now, if we run that, in fact, I think we need to specify. So if we run group equals 1, yeah, there we go. Hang on, what's going wrong there? Oh, wait a sec. I need to include the group equals 1 inside this. There we go. So now it's proportion, I'm sorry about that. There's proportion as opposed to the count. So this says that about 40% of diamond cuts are ideal. Now, another possibility is another reason why we might change the default stat or statistical transformation is that we might want to really emphasize the statistical transformation in our code. So maybe we want to use stat summary, which will actually give us some more detail. So to do that, let's use this example. So if we put this in here, so we're going to run this, and this will give us some more detail about our data. So now we actually have I think it's the median depth here, and we have or the mean, and then we've got the minimum and the maximum as well. Okay, so next we're going to look at the position adjustments. So let's come back to our bar plot. So we can actually, as you might have guessed, we can actually specify, so we're going to just simplify our bar plot. We're going to specify just x equals cut. Now we're going to use our color. Now, if we run that, we have a very simple bar plot. But what if we want to really split out our bar plot and use, maybe we want to specify that color equals cut. So if we run that, okay, so this is looks a bit ugly because it's only putting the color around the edges. But if we use fill equals cut, so fill equals cut, that is a bit easier to see what's going on. Now, what happens if we map the fill aesthetic to something else? What if we call it clarity? So let's use clarity of the diamond. So now, what we can see is that R is actually stacking these on top of each other. Now, the trouble is, it's kind of hard to understand what this means. We can change how R is displaying this by using the position argument. So let's have a look and see. So first of all, if we change, and this has to be outside of these parentheses, outside of the aesthetic, if we change position is identity, then they'll actually overlap with each other. So we can actually see that most clearly if we specify that alpha equals, let's say, like 0.2. So we're going to make it transparent. And now we can actually see that they're overlapping with each other. Well, that's not very useful. So what we can do is we can also use a different type of position called position equals fill. So if we do that, it will actually make them, whoops, I just need to get rid of my transparency there. Now it will make them all the same height, which lets us basically compare the proportions across different groups. So the proportion of the clarity of the diamond across different groups. Now, the final one, which is what I prefer to use, is instead of position equals fill, it's position equals dodge. So what this does is it actually splits out. So for each different group, for each cut, we actually have the clarity, which is split out into a separate bar. And that makes it much easier to compare across different cuts to see which ones are most prevalent. Okay, now there's one more example I want to have a look at here of how we can do position adjustments. Remember our initial point plot. So if we come back and go and look at geom point, and we're just going to use, we're going to specify our x is our displacement, remember, and our y equals hwy, and let's run that. Whoops. Oops, yeah, that's right. It was wrong data. There we go. So if we go back to our original data, there we go. So you'll see here that, well, when we look at the actual MPG data, there's actually 234 rows. But if we were to go and count this plot, there's actually only 109 values. So why is that? Why are there only 126 points on this plot? Why are there only 126 when there's 234 rows in our data? Well, basically what happens is that because these points are so close to each other in this data, they actually are put on top of each other. Now, to get around this, we can use another position adjustment, which is called position equals jitter. So if we use position equals jitter, that puts a small amount of random variation in the point positions, which actually gives us a bit of a clearer sense of where they are positioned. And because this, particularly with really large plots, this can be a really helpful way of actually seeing where most of your data lies, because obviously if points are being put on top of each other, technically that is a more common point, but you don't see that if it's only shown as one point. So in fact, because people use this so often, there's actually a shortcut for this, which is just geom jitter. And so you can just run it like that, and it will give you the same result. So it's a random difference each time. Okay, so we're coming near to the end. The final thing we're going to look at is we're going to look at coordinate systems. So let's generate a box plot. This is another type of geometric object. So let's come back to our data, and we're going to use geom box plot for a box plot, and we are going to run like that. Whoops. Okay, wait a sec. We're going to specify our x as class and our y as h. There we go. So now we have a box plot where it shows us basically like the metrics for the HWY or the kind of the fuel efficiency based on the class of the car. Now, the transformation we're going to make here is one called coord flip, and that will actually flip the x and y axes. So if we run that command, so we'll add coord flip to the end, it flips our axes. So now what was on the x-axis is now on the y-axis and vice versa. So this can be really helpful when we have long labels and we want to show them better. Now, we're not going to go into a huge amount of detail on this, but you can do a similar thing for maps. So let's just run these commands to generate a map. Oops. We don't actually have the map data installed. We're going to install the maps package. So we're going to install maps like that. And then as this installs the maps data, so this is the command that you can use to install any package in R. So if we install the maps data, and now we're going to, so first of all, we're going to get the New Zealand maps data, and now we're going to actually build this plot here. So this will be basically generate a map of New Zealand, if we wanted to add the coordinates, make the coordinates look good, we can actually use another coordinate transformation, which is coord quick map. There we go. And now the aspect ratios are much better. So we're not going to go into a huge amount of detail about map data, but this is another example of how to do a coordinate transformation. Next, let's look at polar coordinates. That's another type of coordinate system. So if we had, let's say we had this particular plot, we're just going to copy and paste this code in here, and we just ran bar. So if we just run that, we see this bar plot. Well, if we wanted to we can use coord flip. So that's one transformation. But the cool thing is, what if we wanted to use the polar coordinates? To do that, we can actually run coord polar, and we get this really interesting plot where we're basically seeing the same data set, but it's represented using polar coordinates. So that is super interesting. Now, there's one more thing I wanted to show you, which is that a lot of this data, so if we want to do multiple transformations, let's say we want to, let's come back to our original points plot using the MPG data frame. So this is the final thing we're going to look at in this particular tutorial. So let's suppose we have ggplot and we have geom point, and we're typing everything out, and it takes a while to type out. So let's say we're typing our aesthetic. So our x is, let's say our x is the displacement, and our y is the highway, and then we're going to use geom smooth as well. So we're going to use aesthetic, x is displacement, y equals h highway, and so on. We run, sorry, I need to specify the data. So that's important. We'll specify data equals mpg. We run that. We have to keep typing out like these aesthetics each time. Well, the cool thing is we can actually move these back when they're shared. We can actually move them back into the ggplot. And that means that they'll be used by default in each of the geometric objects. So if we just give it like that, now geom point and geom smooth will both use the default aesthetics, which I specified inside ggplot. So let's run that command, and you'll see it generates the same plot. Or we could split things out by getting a color equals, let's say the class. We run that, and whoops, there's a lot of different classes. Or color equals the drivetrain, and now you can see that we're actually saving a lot of typing space by moving everything back into ggplot. Okay, so we've gone through the basics of visualization in R. Just to show you a couple of pointers. First of all, we've covered this chapter called Data Visualization in this excellent book called R for Data Science. I put a link in the description below. This is a fantastic book, and all credit to the authors of that book. And also, if you want to learn more about ggplot, I'll also put a link in the description below to this cheat sheet, which has all of the different types of geometric objects you can use in R. So if you found this helpful, please consider subscribing, and I'll be uploading more tutorials like this in the near future. Take care.